Good evening, students. Today we are going to learn in electrochemistry the important part and important concept is galvanic cell. So electricity can produce it from the chemical reactions. At the same time, the chemical reactions can create the electricity. So in which we have discussed with the two examples. First one is electrolysis of water, and second one is how the function of a galvanic cell. In a galvanic cell, the chemical energy is converted into electrical energy. So now we are going to discuss. Today we are going to discuss galvanic cell. Galvanic cell. We are discussing galvanic cell. In galvanic cell, a chemical energy is going to convert into electrical energy. In galvanic cell, a chemical energy is going to convert into electrical energy. Chemical energy is going to convert into electrical energy. Electrical energy. In galvanic cell, we are using two electrodes. The first one is anode. The second one is cathode. So there are two electrodes we are using here. So we are using two electrodes. We are using. So anode, the rod which is having a negative charge on it, that we call anode. The rod which is having a negative charge on it, that is called anode. So what is cathode? The rod which is having a positive charge on it, that is called cathode. So at anode always oxidation takes place. At cathode, always a reduction takes place. Now, the galvanic cell is a Daniell cell. An example for a galvanic cell is a Daniell cell. Example is Daniell cell. Now we are going to discuss about a Daniell cell. How the Daniell cell working? What is its construction? How in a Daniell cell the chemical energy is going to convert into electrical energy. Now we are going to discuss that. Okay. Put a header here. Okay, Daniell cell. Okay, in Daniell cell we are using two electrodes. The first one is zinc. And second one is copper. Okay. At zinc, you observe zinc is a more electropositive element. If you observe the copper is a less electropositive element. Zinc is more electropositive element. And copper is a less electropositive element. Okay. If zinc is a more positive element, it has a more tendency to lose electrons. Okay. If zinc has a more electropositive, it has more tendency to lose electrons. Okay. Now at zinc, if you observe the zinc, always oxidation takes place. Why? Zinc acts as an anode. Okay. So here at zinc, oxidation takes place. Why? Losing of electrons is called oxidation. At zinc, oxidation, always oxidation takes place. Losing of electrons is called oxidation. So zinc we called anode. Zinc we called anode. So what about cathode? Cathode gaining electrons because it's a less electropositive element. It gains electrons. It is gaining electrons. It is gaining electrons. It is gaining electrons. So gaining electrons, what we call reduction. Here copper undergoes reduction. Copper undergoes reduction. Copper undergoes reduction. So the copper we call cathode. The copper we call cathode. At anode, always oxidation takes place. Okay. At the cathode, always reduction takes place. Now zinc is anode. Zinc is anode. Copper is cathode. What is the construction of galvanic cell? Now we are making galvanic cell. I am taking here one container. I am taking here one container. In this container, I am taking one electrolyte. One electrolyte. I am taking here one electrolyte. For example, take here zinc sulfate. Zinc sulfate solution, which is strong electrolyte. Zinc sulfate is the strong electrolyte. So this zinc sulfate is ionizing into ZnSO4. It can ionize in the solution. It gives Zn plus 2 ions plus SO4 minus 2 ions. SO4 minus 2 ions. It is a strong electrolyte. It gives ions Zn dipositive and SO4 dinegative ions in the solution. Over here, I am dipping one zinc rod. I am dipping here one zinc rod, that is Zn, zinc rod I am dipping here. This solution is electrically neutral. This solution is electrically neutral. I am taking one more container here. I am taking here one more container in which I am taking one more electrolyte. I am taking here one more electrolyte. Okay. Here I am taking a copper sulfate solution, CuSO4. This copper sulfate solution, it can ionize. It can ionize into ions. Here it gives Cu2 plus ions plus SO4 2 minus ions. So this solution also electrically neutral solution. So in this copper sulfate solution, I am dipping here one copper rod. I am dipping here one copper rod, that is Cu. I am taking here one copper rod, Cu. These two electrodes, okay, I am connected to the external circuit. I am connecting here to the external circuit. Over here, I am keeping one voltmeter. I am keeping here one voltmeter. Okay, this circuit is not completed. It is open circuit only. To close this circuit, I am keeping here one inverted U tube. One inverted U tube. This is one inverted U tube, and this is one inverted U tube. Here one inverted U tube I'm taking here. One inverted U tube I'm taking here. This inverted U tube contains electrolytic solution. Okay, that is inert electrolyte. Inert electrolyte, that is called inert electrolyte. Inert electrolyte. Okay, this inverted U tube contains inert electrolyte that we call K2SO4, potassium sulfate, like a K2SO4 I have taken in this inverted U tube. So it is an inert electrolyte. That means it is not participating in chemical reactions. So this not only K2SO4, I am mixing this K2SO4 with other or gelatin or gelatin. Okay, mixing like paste, a jelly like paste is formed. Okay, this inverted U tube at the sides, okay, the edges, at the edges we are fixed here with the two cotton bonds. Or here at the sides of the inverted U tube, I fixed two cotton bonds. So this inverted U tube we call salt bridge. Salt bridge. This inverted U tube we called salt bridge. This salt bridge contains inert electrolyte like K2SO4. It is mixed with the other orange gelatin. Okay, they are mixing and form like a jelly-like paste over here. So here a jelly-like paste is forming here. Okay, here we are making jelly-like paste. Jelly-like paste. Now the circuit is completely closed. So here zinc is acting as an anode and copper is acting as a cathode. Okay, zinc is acting as anode, and copper is acting as a cathode. Okay. So here, if you observe at anode, what is going on? At anode, always oxidation takes place. For example, I am taking a zinc sulfate solution. So this zinc sulfate, this zinc is losing electrons. It forms Zn plus 2 electrons. It is losing electrons. Okay. At anode, always oxidation takes place. Zinc is going to lose electrons. This is called oxidation. Okay. Here the 2 electrons are released. Here, this is the 2 electrons are released here. Okay. From Zn plus 2 and here Zn plus 2. So 2 electrons are released here. These 2 electrons are accumulated on the rod. The rod gets a negative charge on it. The rod contains a negative charge. So this negative charged rod we call anode. The negative charged rod electrode we call anode. At the same time, if you observe this copper, the copper in this solution it forms Okay, Cu2 plus and SO4 2 minus ions. Okay, these electrons are going from here to here. This copper is electron deficient. This is electron deficient. This is electron deficient. So the electrons which comes from the anode, it's directly these electrons. Okay, these electrons are taken. So here these electrons are taken by the Cu2 plus. So this Cu2 plus takes the electrons and it forms Cu. Here it is deposited over here on the rod. It is deposited over here on the rod. If you observe here, this copper is losing electrons here for giving this Cu2 plus. It forms a positive charge on it. It forms a positive charge in it. So that is called cathode. That is called cathode. So at cathode always a reduction takes place. At cathode always a reduction takes place. At cathode always reduction takes place. If you take CuSO4, this CuSO4 solution, okay, here this Cu2 plus, this Cu2 plus gaining electrons here, forms Cu. It forms Cu, okay. This Cu is deposited on the cathode rod. This Cu is deposited on the cathode rod. So here it forms a positive charge. The rod which contains a positive charge on it, that we call cathode. At cathode always a reduction takes place. At cathode always a reduction takes place. Zinc is acting as an anode. Zinc is acting as an anode. Okay. Copper is acting as cathode. Okay. We observe here in anode, the zinc sulfate solution is formed Zn plus 2 and the SO4 minus 2. Okay. At anode, always oxidation takes place. At anode, always oxidation takes place. For example, take here zinc. This zinc is losing electrons. It forms Zn plus 2 electrons. Okay, this is called oxidation. At anode, always oxidation takes place. Okay, here this zinc 2 plus is formed. Zn2 plus. So these Zn plus 2 releasing into the solution. Okay, now the solution became completely positive. The positive solution. So the electrons are released. What electrons are released here? These electrons are accumulated on the rod. These electrons are accumulated on the rod. So the rod contains a negative charge. The rod contains a negative charge due to the accumulation of electrons on the rod. So this electrode we called anode. Anode contains a negative charge. Okay, the electrode which contains a negative charge, that is called anode. Now come here. Here Cu2 plus. Cu2 plus is a electron deficient. Electron deficient. So due to the deficiency of electrons, this U2 plus is taking 2 electrons from the copper. This is copper rod. So from here, this 2 electrons is taken. Okay, 2 electrons is taken. Now the copper is became a positive. Okay, now the copper became a positive. So, okay, this the rod which is having positive charge on it, that we call cathode. That we call cathode. So this process is called a reduction process. This Cu2 plus, this Cu2 taking 2 electrons from the copper rod. Okay, it forms Cu. Okay, it forms copper. This copper is deposited over here on the rod. This Cu is deposited here. This copper is deposited. Okay, at cathode always a reduction takes place. At cathode always a reduction takes place. At the anode always oxidation takes place. At anode always oxidation takes place. So mix these two reactions. Okay, what you get here? At anode, okay, at anode what is the reaction? That is zinc is losing electrons. It forms Zn plus 2 electrons. At cathode, the copper 2 plus gaining 2 electrons from the copper, and it is deposited as a solid at a copper rod. Okay, it is deposited as a solid. So now the overall reaction is we observe here. Okay, from the both sides the electrons are cancelled out. Now you get the overall reaction. Zn is a solid. It's reacted with the Cu, the 2 plus aqueous. You will get this Zn plus 2, okay, aqueous plus Cu, solid. This is the overall reaction. This is the overall reaction. Okay. Here zinc, which is losing electrons, these electrons are accumulated on the rod. So these electrons are moving from anode to cathode. Why? This rod has a negative charge, this rod has a positive charge. This negative charge is attracted to positive charge. So that is why the electrons are moving from anode to cathode. The electrons are moving from anode to cathode. You can see, in voltmeter, it can be the reflected. You can observe the visibility. You can see in the voltmeter the reading will show. Okay. So here the electrons, the direction of flow of electrons from anode to cathode. Okay. At the same time, the electricity or current. Okay. The direction of flow of electricity from cathode to anode takes place. That is exactly opposite direction. Okay, right here, the direction of flow of electrons. The direction of flow of electrons. The direction of flow of electrons, anode to cathode. Anode to cathode. Okay. Now, the direction of flow of electricity. Direction of flow of electricity. The direction of flow of electricity is from cathode to anode. From cathode to anode takes place. Okay. So this is very important now. When we connect the salt bridge, the flow of electrons from anode to cathode takes place. At the same time, the electricity or current flowing from cathode to anode takes place. That is exactly opposite direction. Okay, you can see the reflection in voltmeter, it is visible. So this is how the Galvanic cell is working. Okay, this is how the chemical energy is going to convert it into electrical energy in Galvanic cell. That is the function of the Galvanic cell. In this reaction, if you observe clearly, so here the Zn2 plus ions are released into the solution. The Zn2 plus ions are released into the solution. Okay, now the thickness of the copper rod is zinc rod is decreased. the thickness of the zinc rod is decreases with time. At the same time, if you observe the copper, the Cu2 plus ions taken by the copper rod and it is deposited as a copper here. As a solid, it is deposited. So here the thickness of the copper is increases. Okay, here zinc thickness decreases. Okay, copper thickness increases with time. Okay, now we are going to learn, so what is the use of the salt bridge here? Okay, how it is working.